Hello, everyone, and welcome to Time to Wake Up, How We Can Win the Race to Net Zero Buildings, a special live event brought to you by the B1M in partnership with IES. I'm Fred Mills. I'm the founder, face and voice of the B1M, and I'm going to be your host for today. And I'm excited and also quite relieved to say I've got some fantastic industry experts joining me, all of whom know a lot about this subject area and can provide a lot of information and knowledge to you over the course of the next hour. Now, we're going to meet them in just a moment, but before we do that, I just want to give you a little bit of housekeeping. We're going to run for about 60 minutes, as I said. I'm going to start by introducing the panelists. We're then going to have a quick overview of the subject area for those of you who maybe aren't aware of the topic we're talking about today. We're then going to move into some pre-prepared questions for our panel, just to make sure that you guys get the key messaging and key takeaways from today's session. But then we want to hear from you. We want to answer as many of your questions as possible, so please do get them coming in. You'll see there's two features on Zoom. There's a chat feature and there's a Q&A feature. If you get your questions coming into the Q&A feature and keep that just for questions, that'll enable us to answer as many of your questions as possible, as quickly as possible. You keep all other kind of discussion, debate in the chat. That would be much appreciated. Before we get going, let's meet our panelists. First of all, we've got Don McLean from IES. Don.
Hi, folks. My name's Don McLean. I'm the founder and CEO of IES, and I'm delighted to be in this presentation today with some really good people. So hopefully you'll enjoy this. Thank you.
Thanks for being with us, Don. Carl's joining us from CIBSE.
Yes. Hello, everybody. My name's Carl Collins. I am the head of digital engineering at CIBSE, which is the Chartered Institution of Building Services Engineers. I'm also the founder of the Society of Digital Engineering, which is a CIBSE society.
Fantastic. Thanks for being with us, Carl. Gillian, you're joining us from the Energy Managers Association.
Yes, hi everybody. Thanks very much for having me along today. My name's Gillian Brown. I am the Vice Chair of the Energy Managers Association, which for those of you who don't know is an organisation that represents energy managers across the UK. As an aside to that, I'm a PhD researcher at the University of Glasgow, and my main focus for my research is the digital inputs available for digital twins in higher education estate. Thanks.
Fantastic. Great to have you with us. Chris, you're joining us from Perth and Kinross Council.
Hello everybody, I am the lead energy officer at Perth and Kinross Council. For you that don't know where Perth and Kinross is, it is a district in Scotland.
Great, thanks for being with us, Chris. You put your district on the map. So, and Todd, you're joining us from Gafcon Digital.
Yeah, hi, Gafcon Digital, based in San Francisco. We are a systems agnostic systems integrator. We've recently gone through several recent acquisitions, but really focused on the digital building lifecycle, leveraging digital twins for building advanced building performance and sustainability, as well as overall decarbonization.
Fantastic. Thanks for being with us. Well, as I said, guys, we've got as you can see, fantastic panel of experts from right across the globe today. A really great panel brought together by IES. And it's a privilege to have them here in person, albeit virtually in person, and to be sharing this conversation. Now, before we move on into too much of the detail, we want to highlight that there is a special white paper that's been published today. So it's a special day today. You've not just got this great live event, you've also got a free collaborative industry white paper that you can download. It is available to download now over on the IES website. There is a link in the chat feature on Zoom. So if you can't memorize this URL and space for a few seconds, the link is available in the chat feature. It's also on the IES website homepage. You can find it from there. It's fair to say, and I'm not just saying this, but I've seen my fair share of construction industry white papers. This one is well laid out, easy to digest, easy to understand, and is a subject area that's important and that really matters to us all. So really worth downloading and having a look through. Some really good information and insight in there, including from many of today's panelists. A bit of context for you, for those of you who may not be aware of the topic we're going to be talking about today. 40% of all carbon emissions come from our built environment. Now, that places a lot of responsibility for climate change and climate pollution at the door of construction, but it also gives the construction industry huge potential to leverage and make a difference in this space. If we can not just build new buildings in a more sustainable way, but operate our existing built environments in a more sustainable way, moving towards lower energy buildings and indeed net zero buildings, this industry, the architecture, engineering, construction and operation and maintenance industry, can really help move the dial on climate change. It really is that impactful. There's a famous saying that you can't improve what you can't measure, and that's very much the case with our buildings. So now through whole life building performance modeling and digital twin technology, we're able to understand a lot more how our buildings are performing, what energy they're using, where and when, and then optimize that energy usage so that we can improve their performance, lower their carbon impacts, but also improve well-being for people inside the buildings, and probably best of all, lower the bottom line and improve financial positions for organizations as well. So it's not just helping the planet, it's not just improving well-being for people, it's also improving margins, and there is a strong business case for this as well. When I talk about a whole life building performance model, and again, you're going to get a lot more detail and proper analysis on this from the panelists shortly. What we're talking about there is a digital model with all kinds of different data being brought into it. So there is the kind of physical architecture, the 3D model of the building or built asset that you may have, and then all kinds of other data being brought into that, whether that's HVAC and loads, compliance data, energy and carbon performance, lighting, airflow, all those things are coming in to give you a digital model, a digital representation of your physical built asset and how it's performing. I've made that incredibly simple. You're going to get a much better explanation from Don in a few moments, as I said. Just to give a bit of an example, this is Irish Life, which is, I believe, the biggest investment and pensions organisation in Ireland, huge organisation. They are using digital twins to understand how their built assets are operating and performing, and they're using that to optimize their performance, again, for all these things, reducing carbon emissions, improving well-being, but also lowering running costs and improving margins as well. This is their IES dashboards. This shows you the kind of data you can get from this, looking at energy use, gas use across a range of buildings in very clear, very easy to see and easy to analyze data, not just for stakeholders, but for the general public as well. And what's really interesting within this is the pathways to decarbonisation that you can pull out of it as well. So this is an example, not for full net zero, but for significant reduction in carbon emissions and carbon outputs through a range of measures up to 2030. But obviously that deadline may change depending on what your organisation is aiming for and trying to do. I just want to end on a big note, because I think there's a tendency for people to think this is quite a technical, geeky area of the industry. It can feel quite specific and quite difficult to get your head around. But if we can understand how a built environment is performing and optimize its energy usage, that can make a huge difference, not just to one building or a district or a group of buildings, but if we can do that across cities and even countries, we can start to seriously reduce the impact that humankind has on the planet through its buildings and leave a better, cleaner, more sustainable world behind for us and our children. It is that important, it is that serious. So try and remember that and bear that in mind when we go through some of the technical stuff that we're going to talk about today. We're going to talk a lot about the how, but never forget the why, because this is really important and really impactful for the future of the planet. It literally is that critical. Just want to flag again, there is that white paper which will do much better justice than I have just done to this topic area, but much more to dive into there. Free to download, as I said, over on the IES website, link in the chat. But if you can't find that or it's not working, go over to the IES website and it's right there on the homepage. Now we're going to bring in some proper experts. We're going to hear from our panel in a bit more detail. I'm going to stop sharing my screen at this point just so we can see everyone nice and clearly. There we go. Don, I want to kick off with yourself, if that's okay. Yeah. Why is the digitization of building performance becoming increasingly important in today's world? And what are the benefits of doing that across a building's whole life cycle?
I think two words: climate change. And that's going to have an enormous impact on us. Although you stated a lot of the good reasons earlier on for all of this, and they're all perfectly valid. But when it comes down to it, we're talking about something that affects every single one of us. And climate change is probably the biggest threat to humanity that we have at this moment in time. So the thing is that the built environment, as you said, is a major part of it. So we need to look at how we can do something about it. And the operation of the building is normally the much longer part of the building life cycle than anything else, but it tends to get ignored greatly. People will concentrate more on the design aspect and not in the operation. I think that's where we've got to make quite a critical deviation to be able to look at this and take this on board. I think also the fact that that we see a much greater emphasis put on the design stage of the building. But once the building is built, then that design is changed a lot. It adapts, and we don't really do anything about it. So the operation, getting control of the operation aspect is extremely important. And I think that you mentioned there about the carbon emissions. They're a major cause of climate change. If we're going to mitigate the carbon emissions, we need to consider ways by which we can decarbonise all existing and new buildings. So in looking at that, we're also talking about in terms of existing buildings, there might be no digital twins there at all for it. So we need to start to look at how we build that to make that happen. But we've got to address both existing and new buildings. And I think that the thing about the operation of the buildings is highly dynamic. So you might set up a building for, say you've got a commercial building, you'd set up maybe an organisation that's good into it, but over the life cycle of that building, you might have 20, 30 recycles of that building in terms of what it's doing and things like that, and how it's used. So as a consequence, it's tremendously dynamic, and you need to try and capture that if we're going to have any impact on climate change. But I think the other thing is that, that if somebody's got to build a digital twin in order to do this, then that's an added cost to them. So the thing is that what we've got is the likes of with IES, we've got what we call a physics-based digital twin, which is different from a BIM type of digital twin. But the two of them actually can work together in a number of ways. So we see that between all of that, what we're really looking at trying to do is find ways in the operation of the building to make it as efficient as possible, and to use the information in that, and for us to be able to manage and control that, to make it as efficient as possible and decarbonise totally if we can possibly do it.
Absolutely, no, I completely agree. The urgency of it and the importance is there. I mean, Carl, bringing you in, I touched on this a bit at the beginning, but how can a whole life modelling approach help building owners better understand their building's performance and then what they can do to improve it? How can you go into a bit more detail about how this process works? Sure,
and I think Don already touched upon this. When we're in the design phase of a building, we're dealing with certainties and a perfect building, and then we bring in people, and people are imperfect. People do things like twiddle knobs on radiators and open windows when the aircon's on. And I remember telling off my kids when we were on long journeys, we had the aircon on and they'd be opening the windows. Unfortunately, people are like that. So the concept of dynamic simulation is one that adds the understanding of what the building is doing, what the people within the building are doing, understanding what the churn of the building is. A lot of open plan office developments will regularly move around people, and you'll have different teams, you'll have different IT equipment, different screens, and also the inputs to the building are dynamic as well. I've been doing a lot of work recently on embodied carbon, which is kind of the twin of the operational carbon, which is what we're looking at here. And we see changes in the grid mix of what power is going into the building. So part of the decarbonisation story is also understanding what is the electrical supply coming into your building and what is that doing to the operational carbon of the electrical equipment. Are we starting to see changes in the gas mix? A lot of people have been talking about hydrogen as a lower carbon fuel. If we start to mix that into natural gas, again, we can use dynamic simulation by looking at what energy is required, but then what's providing the energy is where the carbon is. So understanding that, I think, is really important. And again, as Don said, buildings are around for a long time. Let's say 80% of all buildings that will be around in 2050 have already been built. So we do need to understand our existing stock, but we also need to understand how they are changing, how the operation of a building changes as the climate changes, as the grid mixes change, as technology changes, as working patterns change. I go into the office 3 days a week now. I used to go in 5 days. What has that done to the operational carbon of my office? These things are questions that can be answered through this whole life dynamic simulation. which is put much better on the front cover of the white paper. And it wasn't the word salad I just made.
we can all point to the white paper for improvements, I think, on how we're doing this afternoon. Gillian, I want to ask you, because there's obviously a lot of talk about net zero. It's a term we hear thrown around quite a lot in society, in the media. How can digital twins help us get to net zero buildings? What's the pathway look like?
Sure. I think if we take it back to its very raw sort of the statement of what is net zero, and then we think about what is it we actually know about our buildings, that has a massive variation depending on who you speak to. And I think both probably Carl and Don have touched on a lot of these points, that if we don't know what's actually going on in our buildings, it's very hard to then make a plan to understand how we get to net zero. The digital twin idea and concept takes information that you already have about your building. Doesn't matter the volume, doesn't matter the type of data, but it takes the data that you already have and then makes it useful. And I think it's that overlaying of various bits of information that perhaps would have historically sat very siloed that's the important part for this sort of journey to net zero. Because when you know about what's going on in your building, you can then make a proper plan. So bringing in the bits of information, being able to then start to test things. So rather than doing as perhaps we would historically have done to test, we can now test digitally to see what the actual is going to happen with our building, rather than the old historic, oh, well, it's a roughly 10% saving. We can now pretty much guarantee what these savings are going to be, because by bringing all this data that we already have into the one single place, we can then start to understand how the building is going to change and perform and develop based upon those net zero things. And it's that basic principle of knowing your building and understanding how it's going to behave and react that's the key function for net zero, for any net zero development, because once you have that, your net zero pathway becomes much clearer.
Absolutely. It goes back to that phrase, you can't improve what you can't measure. So we have to be able to actually know what our buildings are doing, first of all. Now, today's event is called, well, the headline for today's event is Time to Wake Up. And that's a nod partly to the urgency of climate change, but also to a new initiative that IES have developed around sleeping digital twins. Don, can you tell us a bit more about how this came about and how IES is trying to use this as a way to increase uptake of the digital twin technology?
Okay. I think we need to start from the fact that what are IES trying to do? So IES is trying to create the technology that can allow us to decarbonise the built environment from the smallest building to the largest building, to cities, to countries, to continents, the whole thing. So how would we solve that problem? So this is what we're trying to do. Develop the technology we can give people that can help them make that kind of impact, because if we don't do that, we all know what the consequences are. So you know, from that side of things, as we kind of see at the moment, there's kind of two kind of digital twin options you've got. One is a kind of BIM-based digital twin, another is a physics-based digital twin. Both of them come from different kind of situations, but people are using BIM to sort of try and do some operational aspect, and what we're trying to do is develop through the physics side something that is a bit more comprehensive and effective. But one of the things that's happened is that we estimate that there's probably been about 1.5 million medium to large buildings done around the world with our technology, and virtually all of them have been archived. Okay, so they're not used yet. They're a tremendous asset to that building. So as a consequence, what we're saying is, what do we do there? So the simple thing is that in effect they're sleeping, they're not being used. So if we bring them out, waking them up and start to try and use them, you know, yes, we'll need to kind of wake them up a good bit, but the idea being is the fact that the people can resurrect that, make the adjustments to it, and they have something much faster and quicker than actually having to go and build a model from scratch. Yes, they need to look at the building and they start to update it a little bit, but you've got something there. Ideally, what we want to do is you don't go to sleeping, right? But there are so many of them available. And also in the BIM side, you've got a massive, you probably get tens of millions of sleeping BIM-based models. And what the concept there is the fact that they're still a sleeping digital twin in the context that they can be brought up to date. And once they're brought up to date, they can be imported the way we import that kind of information into our software. And then people can start to use that to access our capability, looking at how we could decarbonize those buildings and start to look at how we can do different ways of doing it. So you've got, everybody's got, there's lots of people will have that kind of asset sitting there. And it seems very simple just to update it in that kind of way. And it's not going to be a massive saving, but you've got an asset there, start to use it rather than sitting there doing nothing. So what we see is the fact that we want to try and awaken as many of these sleeping digital twins as possible, be they a BIM model or be they physics-based. But the idea being we get them all into the physics-based as quickly as possible and start to use that and link those buildings together and start to look at how we can then start to look at decarbonising campuses and start look at communities and start looking at cities and start looking at continents. That's the kind of objective.
Absolutely. So again, just to underline people listening today, you might not realise, but you could well be sitting on a sleeping digital twin. You already may have this information. You haven't got to go from zero up to what we're talking about today. You may already have a lot of the model information from the design and execution of your building, and that's what the IES digital twin is about. It's about waking that up and putting it to better use as a digital twin. Chris, I want to bring you in if it's okay, because there's sometimes one of the barriers that's talked about in the white paper is sometimes a lack of awareness or understanding from clients about what building models actually are, what building performance models are, and what the advantages are of using them. How do we get around that problem? How do we tackle that problem?
I think there's obviously a lot of upskilling that needs to be done. A lot of obviously exercises and webinars like this are very important as well, sharing knowledge and sharing lessons learned. So it's very important that collaboratively across even Scotland, we think about, we've got an energy officers network. When we talk about projects, we need to be sharing the benefits of the things like digital twins and what we're using them for. And they're not just, we're talking about climate change and we're talking about energy reductions, but I think it's been touched on briefly, the design element to construction, what a model does, it genuinely builds that gap and you can get an understanding how your performance of your buildings are going to be prior to it. And when you're thinking about clients and how it can support them, money's tight and decisions that we make it can be hugely impactful. So we need to think about how we're spending that money, and there's no better way than trying to put something in a model to understand the benefits you're going to have before making full investment. And I think that's what we're finding definitely when we're working, how positive some of these changes can be, and putting them through a model to understand the outputs prior to even construction starting. I think Don touched on it as well, and so did Carol, bringing these into design stages and operating these builds and changing models to kind of understand the implementations of design decisions and how that can change the kind of forecast for energy reductions and carbon reductions is huge. But it's not just about that for us. You think about climate change as a whole, you've got potential for overheating that you bring in here, you've got occupancy that you're bringing in. I think there was talk about change in the use of buildings. Like, all this information can be built into your model, and for the client to understand the impacts that's going to have. We've done things such as like switching heating systems off from May to October, what effect that has on our energy. And you can run that through the model, and just by simply putting in profiles and turning off your heating and see what impacts it has. Changing, heating going off from 16 degrees when the temperature's outside because you've got weather data files attached to these digital twins, what impacts that has on energy. So it's not just about the investment into kind of renewable low carbon sources, it's about behavioural changes on sites and the impacts that they can have. And a lot of that is genuinely, there has to be upskilling. There is a huge amount of expertise out there in young people that are doing, university course and engineering courses and trying to get into this industry. And there's definitely opportunities for a lot more people to come in and be working on these models, because it's you're seeing it's hugely impactful on the jobs that we're doing, and it definitely will benefit us going forward.
Absolutely. And for local authorities, local councils that have a number of buildings they're trying to operate and manage, sometimes without sufficient resources, having more information and data on that can only be a good thing, right? It makes the process easier, effectively.
Yeah, absolutely. If you think about, we're talking about creating digital models, and what Don said, the information's already there. Councils are very much like that. You've already got, planned drawings of every single building, and you've got service and asset information that you've got there. You literally have all the information there. If you can get people in there upskilled who can design these models for you internally, you literally have models already being built from people within your office with all the information already there. And then you can start to share that knowledge across the board, and it impacts decisions not just on projects, but anything we can do. And it's crucial for local authorities, because we don't have a lot of money, and there's not a lot of money to go about. So decisions you make are very important, and we're trying to get to the net zero targets, and we'll be the lead in a lot of this, and leading the sector. So it's important of what we do is right, and we've tried and tested it as well. And that is the thing. We've got, I think Gillian touched on data. We're unloaded with data. You know, if it's half hourly data, if it's metering data that's pulled back through, these are all built into your digital twins as well. So you've got a predicted model against actual use, and then you can feed back into lessons learned, etc. So there's a lot of good work that can come back from the digital twin.
Yeah, absolutely. Todd, I want to ask you, because there's the kind of themes in the white paper around who owns the model, who should own the model, collaboration, access to the information and data once it's out there. Can you speak to that a little bit? How crucial is it that these digital models are easy to access, manage, and share?
Yeah, thanks for that, Fred. Really good question. I'm coming at it from, our team is coming at it from a slightly different angle, in the sense that we really only work for building owners. And as part of being in the ownership position, we're looking at the full digital building lifecycle. And with our owners, we try to develop this metaphor of promoting designing with the end in mind. So if you understand that what we're setting up foundational platform-wise, and we're really focusing on the end operational result, which is really where the carbon and energy use is coming from, that's the biggest impact. So I'm looking at it from the focus of an owner of de-risking investments and looking at risk mitigation, but consistency. And therefore, we've set up a BIM standard that really develops a baseline for how all the stakeholders design, build, and operate the buildings. So that, I think Don touched on this before, the BIM standards really being that static model. The dynamic model is really what we're talking about from an operational perspective. And that brings me to something that we call the digital thread, and the consistency of data validation from early stage planning all the way through back-end operation. And something that the industry is starting to focus on is more of the closed loop analysis and the validation that what we designed to is actually being operated the way it's supposed to be. So risk mitigation, cost consistency, and standards across the full life cycle is really something that we are focusing on at scale. One building's nice, but a bigger impact when we can start talking about master plans, data centers, city scale application, building portfolios. That kind of scale is really going to help us get to the decarbonization goals that many of our owners are looking for.
Absolutely. I think the business case and the advantages for this approach are really clear. I think we can all see and understand the benefits of taking this approach. I think one of the big challenges, and it comes up in the white paper as well, is that initial investment of time, energy, and cost to a point to make this happen. How do you think, this is kind of a general question to all the panel, how do you think we can convince not just the construction industry and the architecture industry, but also building owners and operators to start to do this as a no-brainer rather than something they feel they have to do at the moment? How do you think we can move it to something they choose to do for their own benefit?
I think one of the things that we've experienced since all of this BIM stuff started, what was it, 10, 15 years ago, is we now have contracts to facilitate collaboration. And I think this would be an extension of that ethos, where if the client is aware of what they want, which is a bigger question than it sounds, because not all clients are aware of what they want. But if we can help raise that awareness, then they can write into the contract to say part of the deliverable is the virtual representation of what you're actually building for me. So the physical asset is our primary deliverable, but having a virtual asset as a twin deliverable I'm using that word advisedly apparently, then it gives you the impetus to get up and running. And as Dom said right at the beginning, you know, these things exist. We do them anyway as part of the design process. There will be some hurdles to jump over for sure. There's probably things like intellectual property and professional indemnity issues that will need to be sorted out, but it's nothing that's insurmountable in my view.
Absolutely.
Fred, can I just
I think I can.
I think I really agree with what Carl was saying there. But the one thing I think that I would see is that if you follow it through kind of logically, you know, we're talking about how the industry can adapt to this. But I think that what's happened is it's such an important aspect that people will adapt to it. And it may be from different sectors of the industry and things like that. We could see a dynamic change to the way that buildings are built, looked after, and all this kind of thing. If the existing people in those positions don't take the responsibility and do something about it, then someday will come in and do that. So we could see a radical change in the way that buildings are built, constructed, and looked after. But that's going to come through the actions that we take now going forward. And I think it'll be an interesting something to look at if that type of thing happened.
One of the things, Don, I'll piggyback off of that is people and owners seem to be very data driven, always asking, we need data, we need more data. And a lot of times that data just sits on a shelf, not really being put to work. So what we're all about, our focus is, what do you do with the data? And that's really the important part. You can collect data all day long, but if you're not activating it or putting it to use from a dynamic perspective to make intelligent decisions, using virtual time and virtual money before you make real investments, that's really where the value of these digital twins exist. And underlying closes the loop on why these are so important for owners and the industry to be making investments in.
Absolutely. Don't forget, if you're listening, guys, I'm going to come to your audience Q&A shortly. So please do get as many of your questions as possible into the Q&A feature on Zoom. We've got a much better chance of answering them if you put them in the Q&A feature on Zoom there. So do get your questions coming in, because we're going to come to those in just a moment. Before we get there, I just want to ask each of the panel a clear takeaway, really, is what's the one overriding piece of advice you'd give the audience from today? How can they get started with this? What are the first steps they should take? I'm going to start by putting Gillian on the spot first, if that's okay. Just work.
It's not a problem. I would say, as somebody who has been at the beginning of this journey a few years ago, it seems very overwhelming, I think, because there seems to be a huge amount of technical stuff that you need to think about, and the detail and the design and stuff. But what I would say is, you probably have enough information already to start somewhere. And I think it's that you have to start with a small amount of data. Don't expect to build this with everything that you're ever going to need, because you'll never get there. And it will just take so long that whatever you have originally will be so out of date. So start small and then build upon it. And I think that's the luxury of a digital twin, is that it can be added to as you go along and you gather more information. So don't put off something because you don't think you've got enough. Start with what you've got and you can build on that.
Absolutely. Todd?
Yeah, I would have to agree with that. A lot of our owners are skeptical about the value of a digital twin, or it might be overwhelming for them. So we typically start with a proof of concept and say, okay, let's just look at one building. Let's see what we can do with that. You've already made an investment from an energy model, Title 24 in California, ASHRAE 90.1 across the US, and there's other international compliance metrics that are used. So bring those investments back to life, and let's just start with one model that you've already made an investment in. And once they start to see the value of that over time, they are more willing to make investments. And once they see the ROI, they can say, okay, well, if we can make these investments, we can then project what our cost savings is going to be, not only from an initial investment, but more importantly, from a longer term investment strategy. And that's where where we really start to see a return on investment for our owners.
Don.
I think we look at the classics example of crossing the chasm. What we're doing is we're dealing with the early adopters and innovators at this moment in time. So the people that we are talking to are really the front end of this, and they're building it up, and they're the ones that they will help get across the initial chasm and get us into the early majority and take on from there. So it's just a question of how fast we can do that. So we get across the chasm, and then it'll take its own momentum from there. So I think that's something that presentations like this, and also the kind of the white paper we've got, hopefully will get people who are the innovators and early adopters who see it and then can say, I'm going to start to implement that.
Absolutely. Chris, what would you say?
Looking at it from a client's perspective, I'm looking at it that way. I think it's important. You need to learn from others. You need to speak to other people who are on the same journey or already been on the journey and at a different stage. I think what Gillian said, you've been there from the start. We're the same. There's things that you've learned from, and things that you've potentially done that you wouldn't do if you had to do it again. And sharing that knowledge and just being open and honest about the approach you've taken and the good and the bad. And learning from each other, because you don't want to be making the same mistakes, and there's not a lot of time when coming into these. I think it is important, you trial it on a building where you've got the information, you've got that really good detailed information, and you can see the impacts before it's kind of rolled out across the board. If you're doing it statewide or district wide, it is important that you can understand the fundamentals of all the information that needs to go in there, and then the impact it can have prior to to pushing out to kind of overall lots of different buildings. But it is really, really important. I know from my own perspective, learning from others and learning from other people on journeys, other engineers, people in private sector and other people in public sector, it's definitely helped me. You see different angles, different perspectives, different challenges and hurdles that they've had to come over, and you feel that you're working together with these people to get there because you're on the same journey. That's definitely helped. So ask questions, say it to everybody, ask as many questions as you can to get the information you need and the support you need.
Good advice. Carl, what do you say?
I've got two thoughts on this, and one is from the client side and one is from the design, construct and operate side. I think where you've got informed clients, then they can ask their design, construction and operation team, what if we exchange this information? What if we start to use this? What if we feed BMS information into an analytical model? Ask those questions. It may well be that you're working with some very, very smart engineers who say, yeah, actually, we can do stuff with this. The flip side of this coin is a lot of people who build and operate buildings have no interest in building and operating buildings. They want the building for other purposes. Many years ago, I used to design shoe shops for a well-known British shoe shop brand, which was great fun, but they didn't have the faintest interest in what went into their buildings. They just wanted to shift shoes, and that's fine. That's their business. But what we did with them is we said, well, look, we've got all this stuff. Would you like this as an extra service? And the sort of offering up the chain to the less informed clients, I think, can demonstrate to them that we can help them run their businesses in the longer term with stuff that they didn't even know we did. I didn't know we did thermal simulation for a shoe shop in Basildon High Street, but we did. And we can say, okay, you've got a portfolio of 400 shops where you can do new models of your entire portfolio. And then suddenly they're, oh, okay, that's interesting. Keep talking. And it is that conversation. I think, that's been the theme throughout this little question session is talk. A friend of mine once said the best BIM tool in the world is the ear, and the second best one is the mouth.
Very good. Some fantastic advice there. I told you we had a good panel today, guys. We've got some fantastic nuggets of advice from all of our panelists, which is fantastic. Now we're going to come on to the open Q&A now. So we're going to try and answer as many of your questions as we can, guys. Bit of a theme I want to start with. There's a couple of questions asking similar things. We've got one from Charlie Weimer, who's saying, what about existing building stock? And certainly in regions where buildings are 50 to 100 years old or even older, they wanted a cost-effective method of twinning their buildings for decarbonisation analysis. Similar question from Kevin Brady. He's saying, how do we decarbonise public buildings that are in isolated areas or listed buildings that have limited capacity for upgrades? A digital twin would tell you in practice how to do it, but not the reality of how it can be done. So this is talking about older building stock. Julian, do you want to go first?
Yeah, sure. I'm quite lucky that I've actually come from a historic building stock and a couple of different previous roles. So I've had experience of having to deal with digital twinning in this sort of scenario. I would say that you're absolutely right. That whilst you can say yes, in a 100-year-old building, yes, if we just stuck an air source heat pump on the side of it, it would become decarbonised. And then you take that to planning and planning go, no, don't be ridiculous. You're not putting an air source heat pump on the side of a 100-year-old building. I think we can all grasp that sort of concept. But what I would say is that the digital twin part doesn't have to be about things that you can do to your building as an add-ons to your building. It can be about how you manage your building slightly better than you perhaps are doing at the moment. So what we found from doing some really old, we had like 1800s sort of age of buildings, and a lot of people just left them because they didn't really know what was going on within them. But a lot of people had the same kind of attitude where they went, we can't really do anything, so we'll just leave it as it is and it'll just run the way it runs. In actual fact, when you start to bring in bits of data and bits of information, there are some really obvious things that start to crop up that you think, I'm not really sure that building should be running like that. And it's maybe just tweaking things. It's maybe doing things like your operating schedules. It's maybe doing things like your BMS control and your management. It's maybe about the times when you've got occupancy data and then you're realising that your heating's on or off and it shouldn't be, or there's various ways that you can manage your building better. And I would say it's probably that brings the use for a digital twin rather than I'm going to stick a wind turbine in the top of this church spire here, because that's not going to happen.
Good answer. Very good answer. Now there's again a bit of a theme, but it's probably best summed up by Ewan Somerville, who's asked, it's possible to confirm what is the typical hardware and staff resource requirements that you need to enable a digital twin, including data networks, sensors and facilities management. And again, there's a few questions around what's the kind of data you should look for, what's the typical data you'd find in a digital twin in a whole life building performance model. And then just to make this more difficult for you, Ewan has asked, do you think AI will have a role in this field in the future? Silence.
I'll take that. I'll deal with the last bit first, the AI. So we use AI and machine learnings in parts of what we do to look at the performance of a building. But you know, there's a quite a simple kind of analogy here. So if you think about a greenfield site, what can happen is that somebody can come to put a model up on that. You can start to say, right, let's use a BIM model or our model, whatever like that. You can start to build that in. You can start to put some details on it. You could then use that to do an energy analysis, get a feel for its like, look at different options. What PV do I put in? What do I do? What kind of constructions? And as we talked about earlier, you could be doing this for a 100-year-old building that's listed and be doing the same types of things to create a digital twin of that model. And what you could do is the variants, try it out and so what's happening, and look at what's happening and then come up with a decision. If you're AI and machine learning, you can't do that because you need data and there's no data. So we can generate data. We produce data that can be then used. And that gives us a big advantage over AI and machine learning. So yes, AI and machine learning can come on later on in the process and augment what we're doing, but it's not the starting point. Okay, so it means that you've got our digital model from the start. So why would you then go and try and create something from AI when you've already got the physics-based approach or the BIM-based approach already there, right? So I think that's the sort of distinguishing between the two. But yes, AI and machine learning is an important part of what we do, particularly checking for sensors operationally and so on and so forth. But in terms of putting the original model together, for an existing building, for example, we could be taking sensors and sensor information of the building. The hard thing is, can we get the data from the people that have got the sensors, right? So there's a lot of real practical problems at this moment in time that you need to resolve to make this easier. But this is part of the process that I think this meeting is kicking off, right? Is starting to look at how we start to address the operation of the buildings as distinct from the design. and we need to see the operation as probably more important than the design, because that's going to dictate that's linked directly to climate change, which we need to do something about. So I think that's the kind of the key part that I see here.
Definitely. So when we say hardware and sensors, what can you guys give us some examples? What do we mean? What kind of data are we collecting?
So for example, what we'd be doing is we'd be collecting. Don't let somebody else go. Let somebody else go.
Oh, it's so enthusiastic, Carl.
I think one of the things that you really need to consider before going down a digital twin path is the purposes to which you wish to put your digital twin. You can't say to do digital twins, you need to go buy this bundle of stuff. You need to say, okay, I'm going to create something in the virtual, and as an output or outcome from that, I want to achieve these things. And it's those purposes that will define what is the equipment, what is the software, what is the skill set, what is the connectivity to the real. You can't just do a digital twin, because that implies you're doing all of everything, and we're not there yet. We're not at that point where we can have a literal digital twin. We can have, it's more of an avatar of the building at the moment, but we need to understand what we want out of this, and not just say, I want all of everything, and that will define what you need to go and get, what you need to go and learn.
I would add one thing there, Carl. Typically, we've found owners, it's really use case driven. So they'll start with a need for a visualization and understanding certain aspects of the building before they twin it. But once they've got that aspect, we say, well, you've already got this as a platform. What if we do this? What if we do that? And start to show how things might help them from a longer term operational and life cycle cost savings once they start developing the need and the appetite for more and more use cases. One of the other things that we see is sophisticated owners do things, as advanced as laser scanning, thermal imaging, and that's really creating that 3D static model. But once we have that as the architecture or foundation for what else can be done, that gives us the ability to bring physics into it and start understanding performance. And that's really where the focus we should be on is on that operational designing with the end in mind.
Absolutely. We're being inundated with fantastic questions from our audience. Some really great stuff coming in here, guys. So we're going to try and get through as many of them as we can, as I said. One here, which is, how effective is this approach when you're looking at total building energy performance in residential condominiums, where tenants have the freedom to control their own systems and consume their own energy within each individual unit? How can you make decisions that control that on residential properties? I sort of know the answer, but I'm asking you.
Okay, I'll go, right? So to some extent, the thing is that if we could get information from the room, what is its energy consumption, right? And even if it's the worst, if we're getting monthly values, we can use that as a way of kind of calibrating the model to it. But the more information we can get about any of the buildings and the distinction between it, is it a one-person house, two people, what is it? Then we can try and capture the likely occupancy pattern of it, and use that in a way of the basis of trying to get the information together, so that we can then start to predict from there how we think that building will perform with the types of occupants that are inside the building. So it is a complex thing to do, and I think this is one of the reasons why I keep talking about the fact that the decarbonisation of the built environment is probably the most complex of the routes, because every single building, every single room is distinct, and the types of buildings we've got are very, very distinct, and under different climates they are very, very distinct. And yes, it's a big issue of trying to look at the sort of fueling need for aircraft. But if you solve that problem, you've maybe kind of solved most of it. But buildings are much, much, much more complex in how they're used throughout the world. So that's a big obstacle to overcome. And yes, there's got to be some kind of assumptions there, but with inside the tolerance that you need for accuracy to make a decision, we can normally get within inside that level of tolerance and get something that's accurate and give people confidence about what they're going to do.
I've been also talking with some academics on this very topic, actually, and one of their more radical proposals is actual gamification of energy reduction. So if you are in a condominium, you could, for example, say, this is the average unit's energy usage. Can you beat it? Get a free donut or something.
Yeah.
Quite
kind of AI can come into this in that kind of approach.
Just as a kind of sort of slight more perhaps practical way of using the digital twin for these types of things, people tend to have a kind of natural pattern to their life and their life cycle. But it doesn't mean to say that every property has the same kind of pattern. But if we think about the value of a digital twin of a multi-occupant, multi-story building, if you're using that and you get information about that, you can then start to look at when you're consuming power and the types of power that you are consuming. So it kind of opens up avenues to the types of power, the source of power, whether you can store information or data or batteries or these types of things. So again, it's maybe about not necessarily like trying to get people to reduce their power, because obviously people have their own sort of independence to be able to do that. But it's maybe then about taking a sort of slightly a step back, where you then go, well, the types of power and the time that we give the power to different sources and how we store that and when it's going to be used, that type of thing. So it's probably a slightly more practical way of using it.
Absolutely. We've got a slightly more simple question now, but I think it's a really important one to ask. This is from David Bjorkstrand. He says, what's the difference between building performance evaluation and digital twins, or is a digital twin just a tool for building performance evaluation? Simple question, but I think it's probably an important one to get clarified.
From my perspective, building performance is one of the purposes to which we can put digital twins.
Yeah, I think to touch on that, we do it quite a lot on the client side, and we're putting in specifications for big projects. Your BPE is usually done kind of at the end of the project. The digital twin's done prior to that, and it's something that you can almost analyze against your BPE when you're doing a project. That's the kind of the way that we do it within our organization as well. So the digital twin is where you put all that information in, and you've got kind of your standard template of what you're aiming to get in as regards to energy examples, and then your BP is kind of brought in to kind of analyze against that.
Absolutely. We've got a great comment here from Liam Gallagher, who says, if you're telling me digital twins means more donuts than I'm sold. So maybe that's the way to get it across. Another great question here from Sam Riley Gould, who talks about interconnectivity between different types of software and how you can make that work in a digital twin, particularly when you've got potentially different design models from different consultants and designers and different parts of the supply chain. How do we tackle that?
There was some work a little while ago, a year or so ago, to look at this exact issue, the interoperability between software platforms. And you're absolutely right, there is an issue there. It is an issue that the software vendors are certainly very keen to solve, because it means that their platform is more usable with other people's data. And there are some neutral file agnostic languages that we can employ. If we're just moving, say, vector graphics, we've got the old DXF format. If we're moving some more information rich, we've got the IFC language and the various model view definitions associated with that can shift aspects of a model from one platform to another. To say it's perfect would be to overinflate its current abilities, but it is getting there slowly but surely.
As somebody who was a building owner, I feel people's pain when it comes to taking information and putting it somewhere else. And I hate to use the phrase, but it seems to be the one that's commonly pops up all the time now, is open protocol. How open is your data? And interestingly, companies will claim and say that their data is very open and you can send it anywhere across the world, just whatever software system you want. But the reality of that is completely different. And I would say that from research that I have done at this moment in time, because as Don had said, we are probably the early adopters, speaking with the company that you have selected to do your digital twinning is probably the best way to understand how data is going to move between you, as in the system that you have, the data sources, and the system that you choose to put it into, because everybody will be slightly different. Everybody will have a slightly different way of doing it. And even sometimes it's not even just about the openness of the data, it's about the transfer of that open data as well, can become really complex for perhaps organisations who have never had to do this before. If I think of a very specific building management system company that is world renowned, they had never seen a digital twin or put any of their data into it before we went to them and said, we would like to transfer your data from one place to the other. So that type of thing, it starts with conversations, and it starts with everybody sitting down to go, right, what is it you've got and how do we get it to where it is that we need it to go? And various companies will have various ways of doing it.
We've got one very last audience question which we're going to ask. This is from Chris Kitsos, who says, what about safeguarding the real-time data that digital twins use? How are privacy and security guaranteed? I'm sure this is something that's on the mind for many organizations listening, especially in today's world. Don, what's that?
I'll take that again. So the thing is that we obviously have a lot of, but even with our own software, it's to make sure that the data is secure in that, because we're getting information from all sorts of, in our consultancy side, all sorts of buildings, complex, highly sensitive projects, things like that. So making sure the data is as secure as possible is extremely important. And I think the thing is that it's kind of two ways. And particularly, I think on the digital twin side, would somebody kind of hack into that? Well, possibly, because they could create a lot of damage and hold that building or building owner to sort of all sorts of problems. So I think this is one of the things that we're looking at quite seriously in order to get as much protection, particularly in this day and age. With it seems to be getting sometimes easier and sometimes harder to break into systems. So it's just trying to do as much as we can to be one step ahead.
I've been fortunate enough to work with British and international standards, and there are standards around this, particularly on the hardware side, and also with the information management side. There's soon to be ISO 19650 Part 6, which deals with the security of information management. That will be coming out relatively soon. I've been lucky enough to be working on that, so I know what's in it, but I'm not allowed to tell you, which is a real shame, but maybe we'll do another one of these when that does come out. But there is a lot of standardization, and the other thing is keep your firmware updated.
Yeah,
absolutely, good advice. Well, I think a really big thing that's come out of today's session is the importance of talking and having conversations and communicating between organizations, project teams, and supply chains as well. And today we've had a really good conversation to kind of get that started. We've had some fantastic questions from the audience. We've had a really fantastic set of insights from the panel. Don't forget, guys, there is a white paper which takes you into even more detail about this. You can take it away, digest it, go and have a look at it within your organization. We've just shared the link to that again in the webinar chat, but it's also available over on the IES website. So do have a look at that. It is free to download, so really worth doing. I want to say a huge thank you to our panelists for attending today, to Don, to Gillian, to Todd, all the way from California, to Chris and to Carl. It's fantastic to have you here, and thanks for your insights. There will be a recording available of this webinar afterwards, so IES are going to make that available, I believe, in a couple of days' time, but it's definitely going to be up there for you to watch back and enjoy. But just to say, huge thank you to all our panelists, huge thank you to all of you for attending, and a huge thank you to IES for enabling this to happen, and we'll see you soon. Thanks.
Thank you.
Thanks, everyone.
Cheers, guys.
Cheers.